Example 9, Fluid Mechanics, Chapter 6. A pump delivers 610 horsepower to water at 68 degree Fahrenheit as shown. So power of the pump, horsepower, and temperature. In a 6-inch D equals to 6-inch diameter asphalted cast iron horizontal pipe at V equals to 6 foot on a square. What is proper pipe length to match this condition? So in this case, what is L is the unknown. Find from the known power, we can find the head loss, HF, and find F from the power of pump with this relation, where H pump equals to the power on rho G cube. So we know we should find first the loss of the head loss of the pump, which is equals to power 610 horsepower, which equals to the multiply to foot-pound force on the row of water at the specific temperature from the tables is 194 and G is 32.2 multiplied to Q. Q is the magnitude of V on A. We have V here. Let me calculate V on A equals to Q. So Q equals to V Q equals to V point A 6 foot on second as velocity multiplied to the cross section of the pipe, which is pi 6 inch on 12 to convert to the foot. Q can be calculated as foot cube on S. So now we can calculate H pump equals to the feet. Compute the friction factor from the related relation. Now we have the head loss. The head loss of the pump is equals to the head loss of the pipeline. Anyway, we have head loose of the pump. Now we should calculate the friction factor from Reynolds and Epsilon T to calculate our appropriate quantities. Reynolds T, we have this relation, and we have rho for water at a specific temperature. V also is now 6, and D is you can obtain it and also epsilon on D equals to the So from the Moody diagram we can calculate the friction factor, or we can use the Colebrook formula, which is we calculated epsilon on D plus heat calculation or using EAS. We can calculate F equals to this relation. And step 3, find the pipe length. From this relation we calculated the friction factor. The friction factor which can be used to calculate head loose, HF, was equals to the FL on D, V2 on 2G, which is equals to also the head loose of pump. Head loose of the pump is L on the diameter. V2 we had 6 square on 2 multiplied to the gravitational acceleration. With simplification we can calculate L is feet. So we can rewrite the process. The first step is to calculating Q, and then we can calculate the H pump. From Reynolds T and epsilon and D, we can calculate the friction factor F, or from the Colebrook relation we can calculate friction factor. After calculating friction factor, we have HF head loose equals to HP equals to a relation L on D, V2 on 2G. With this relation we can calculate the length of the pipe.